Aspirin is a common over-the-counter analgesic that you will synthesize in this experiment. It is prepared 1 week and characterized the next. By allowing it to air dry in your lab drawer between lab periods, you can determine during the second week the reaction's empirical yield and aspirin's solubility and melting point. Experimental techniques include using a water bath to heat the reaction mixture, collecting the product by vacuum filtration, recrystallizing aspirin from a two-solvent solution, and using a melt-temp apparatus to determine aspirin's melting point. Pertinent calculations include determining the limiting reagent, the theoretical yield, and eventually the percent yield. Aspirin is synthesized by reacting the solid salicylic acid with the liquid acetic anhydride. These two reactants are heated in the presence of phosphoric acid, a catalyst, and the primary product aspirin is formed along with the secondary product acetic acid. A volumetric technique is used to obtain 3 grams of salicylic acid. You'll find at the reagent bench a 3-gram sample inside of a large test tube. You should dispense this volume of salicylic acid into your test tube of identical size. After this dispensing is made, then weigh the amount of salicylic acid on a balance. A beaker containing several hundred ml of water is placed on a hot plate, and the hot plate turned on until the water comes to a near boil. The test tube containing the reaction mixture of salicylic acid, acetic anhydride, and phosphoric acid is then heated in this water bath for 5 to 10 minutes. During this time, all of the salicylic acid should dissolve. If it doesn't, it should remain in the hot bath until it does. After this period of heating, 3 ml of water is slowly added, drop by drop, to the reaction mixture. This neutralizes any excess reactant in this test tube. Then, 40 ml of ice-cold water is added to the reaction mixture, which decreases the solubility of the aspirin, and it should precipitate out at this time. The aspirin is collected in a vacuum filtration apparatus. This is comprised of a vacuum pump, a Buchner funnel attached to the top of the sidearm flask, and then the flask attached to the vacuum pump with a section of vacuum tubing. After inserting a piece of filter paper in the Buchner funnel, the reaction mixture is poured into the Buchner funnel. The liquid component of the mixture flows through into the sidearm flask, and the aspirin product is retained in the Buchner funnel. The initial precipitation of the aspirin is a process called crystallization, where most of the contaminants remain in solution. To obtain a better purified product, the substance must be recrystallized. This is accomplished by dissolving the aspirin in a minimum amount of ethyl alcohol and then adding enough water until the aspirin just begins to precipitate. To calculate the percent yield, you must know 2 values, the actual yield and the theoretical yield. The actual yield cannot be determined until your product has dried in your drawer for 1 week. The theoretical yield can be determined from the balanced reaction and knowing which of the reactants is the limiting reagent. The acetic anhydride is dispensed by your TA in the reagent hood. If you are exposed to this chemical, wash the affected area with copious amounts of cold water. After dispensing the appropriate volume of salicylic acid, remember to accurately determine its mass. Standard safety procedures are required with safety goggles, lab apron, and closed-toe shoes. Gloves are suggested but are optional.